Let's talk about solving quadratics using the factoring method. So in order to factor it, it needs to be in standard form. So the standard form of quadratic there is given to you. Ax squared plus bx plus c equals 0. So the quadratic must be set equal to 0. And some helpful hints are we should keep that a value positive. So we should keep the coefficient on the x squared positive. And then we should also factor out the GCF before we start factoring further. Okay, so remember, this is undoing the double distribution that we did with polynomial multiplication. So we need to factor this back into its two binomials. Well, the first two terms need to multiply to give me t squared. And the last two terms need to multiply to give me 56. And then the middle two need to add together to give me negative 15. So we're looking for two numbers that multiply to 56 and add to give me negative 15. All right, so I could list the factors of 56. I got 1 times 56, 2 times 28, 4 times 14, and then 7 and 8. Okay, do any of those combine to give me negative 15? Yes, negative 7 and negative 8. So t minus 7 and t minus 8. The way we can check this out is see, do your first two terms, t times t, does that give you t squared? Yes. Okay, and then do your last two terms multiply to give you positive 56? Yes, they do. And the last check we got to do is do our inners and our outers. Do those combine together to give you that middle term? Negative 7t plus negative 8t. If I were to combine those terms, those would combine to give me negative 15t. So that's how we know we factored this correctly. But we're not done yet. Okay? We factored it, but now we actually have to solve it because this is an equation. You see it equal to 0. I need this part because it's an equation. I cannot drop that equals 0. All right? So to remember what's next, I'm going to break this apart. So I have t minus 7 equals 0 and t minus 8 equals 0. We're going to use something called the zero product property. But basically what that's saying is t minus 7 times t minus 8. When I multiply those two expressions together, it equals 0. Which means that one of those expressions has to equal 0. It's just like if you had 4x equals 0, you know that that x is 0. Okay? Because anything times 0 is 0. All right? So we had to break off each of these binomials and set them equal to 0. Break off each of these factors, set each factor equal to 0, solve those, and we'll get t equals 7 and t equals 8. Okay, so that's a problem, refreshing you, hopefully, on solving by factoring. Next up, in the second problem, 3x squared minus 15x minus 42 equals 0. It's set equal to 0. Are my a values positive? Does this have a GCF? Well, yes. There's 3 goes into 3, negative 15, and negative 42. So my first step is I'm going to factor out the greatest common factor. I'm going to factor out that 3. I'm going to be left with x squared minus 5x minus 14 equals 0. Okay? Now, what I can do is I can divide both sides by 3 just so I can be left with x squared minus 5x minus 14 equals 0. I don't necessarily need to see that step from here on out, but just know that when you factor out a GCF, you can divide both sides by that GCF as long as it's a number, just to get rid of it, just so you're dealing with x squared minus 5x minus 14 equals 0. So next up, I need to factor this. Don't forget that it's equal to 0. This is still an equation. Okay, so the first two terms got to be x and x, because they got to multiply to x squared. Last two terms need to multiply to negative 14, and then the inners and the outers need to combine to give me negative 5x. So what multiplies to negative 14 and combines to give you negative 5? That'd be minus 7 and positive 2. And you could have flip-flopped those. You could have had x plus 2 as the first binomial. That doesn't matter. All right, but from here, split off each of these and set them equal to 0. And I'm going to get x equals 7 and x equals negative 2. Let's keep rolling. In this next one, we've got 2x squared minus 25x equals 3x. I need to set it equal to 0 first. So my first step is to set this equal to 0. Next up, look for a GCF. Well, they both have a 2 in common, so I can factor out a 2. And with the variables, they both have an x in common, so I can factor out an x. And I'm going to be left with x minus, oops, that's messy. Sorry. X minus 14. So 2x times x minus 14 equals 0. All right, that's all I can factor. That's as much as I can factor. So now that I have my two factors, 2x and x minus 14, I can split those off and set each of them equal to 0. Well, 2x equals 0. If I solve for the x there, I'm going to get x equals 0. And x minus 14 equals 0. If I solve that, I'm going to get x equals 14. So for this one, x equals 0, x equals 14. All right, let's keep moving along. Here, we got a complicated looking equation here because we've got terms on both sides. I need to get it set equal to 0, and I'm going to do it so that my a value stays positive. It's going to help me when I start to factor it. So in order to keep my a value positive, the coefficient on the x squared, I'm going to move everything from the left-hand side over to the right-hand side. So 0 is going to equal x squared plus 17x minus 138. Okay? And I know we usually don't have the 0 first, but we can. And if you want to rewrite it as x squared plus 17x minus 138 equals 0, by all means do that. Okay? So from now, there's no GCF. So I'm going to go straight into trying to find the two binomials that when multiplied together equals 0. Okay? So x squared plus 17x minus 138. I know it's x and x. Right off the top of my head, I don't know two numbers that multiply to negative 138 and add to give me 17. So I'm going to go off to the side here. I'm going to start to guess and check. What multiplies to 138? Well, I got 1 and 138. Let's see. I've got 2 and 69. I have 3 and 46. Well, no way for those to combine to give me 17, so I got to keep going. 4 doesn't go evenly. 5 doesn't go evenly. What about 6? 6 and 23. Well, 6 plus 23 is 29. But remember, these need to multiply to give me negative 138, which means that one of my numbers is going to have to be negative. What about negative 6 plus 23? Negative 6 plus 23, that's going to give me positive 16. So I'm going to have x minus 6 times x plus 23. That's going to equal 0. I branch these off and I set each factor equal to 0. And so I'm going to get x equals 6 and x equals negative 23. All right, we got two more examples. In this next one, x squared plus 11x plus 208 equals 180. Got to set it equal to 0. Subtract 180 from both sides. So I'll have x squared plus 11x minus 28 equals 0. From there, I know it's going to be x and x. All right, two numbers that multiply to negative 28 and add, oh, sorry, not negative 28. Hang on, that should be positive 28. Should be positive 28. Two numbers that multiply to positive 28 add to 11x. That's going to be 7 and 4. So x plus 7 times x plus 4. Remember, you can always double check that you factored it correctly by checking your inners and your outers and making sure they combine to give you 11x. Checking that your last two terms multiply to 28 and your first two terms multiply to x squared. Don't forget that. Okay? But it is factored correctly, so I'm going to split this off and set each factor equal to 0. And I'll get x equals negative 7 and x equals negative 4. Okay? Those are the values that if I plugged it back into the original equation would make that true. And now for our last one, I got a challenge for you. It is already set equal to 0, but our a value is not 1. So this is a little trickier. What two numbers, my first two terms, remember these two terms here, need to multiply to give me 2x squared? What's going to multiply together to give me 2x squared? That's going to be 2x and x. All right? And then the last two terms need to multiply to give me negative 3. Well, what multiplies to give me 3? It's going to have to either be 1 and 3 or 3 and 1, depending on how this goes. All right, so first off, this is our guess and check method. I'm going to try 1 with the 2x and 3 with the x. Now to check this, I'm going to do inners and outers. Is there any way my inners and my outers, when I combine them, 1x and 6x, that I can get positive 5x? Yes. If the 1x is negative and the 6x is positive. But here I have to double check one last time. Do my last two terms, negative 1 times 3, does that give me negative 3? Yes, it does. So that's how I know I factored it correctly. From here, I split this off. I split each factor off, set them equal to 0. Okay, so in this first one, I'm going to get x equals 1/2. And here I'm going to get x equals negative 3. All right, so this last one's definitely a challenge. In the next video, I'll talk about another method that might be a better or a faster way to solve those types of problems. But for everything else, factoring should be very quick. Okay, like t squared minus 15t plus 56, boom. We should know that's t minus 7 times t minus 8. So you definitely want to make sure you're practicing this factoring method because we are going to use this skill a lot, not only in this class, but your future math classes as well. If you have any questions, let me know. Other than that, just make sure you practice.